Hello and welcome in to the example problem video for lesson 10 for Precalculus 2. In this video, we're going to look at various examples of applying our sum and difference formulas that we looked at in the content video. Share my document camera with you guys. All right, so we have the following type of problem. It'll say use the addition or subtraction formulas to find the exact value. So again, let me just point out here, when these problems, be it in WebAssign or be it on an exam, say find the exact value, this means a couple things. First of all, no decimals. So you should not be using your calculator to figure these out. Obviously, if I wanted sine of 75, I could put that on my calculator and get the answer. That's not what we want here. We want to apply the sum and difference formulas. So no decimals, which means how can you solve these? You're going to have to use the unit circle. So if you're doing these problems and at some point during the problem you're not using your unit circle, you're not doing them correctly. So let's look at the first one. Let's say we want cosine of 195 degrees. So we can break this thing up, either adding angles together or subtracting. I could do like 200 minus 5 if I wanted, but that doesn't really help me, right? Because I don't have 200 and I don't have 5 on my unit circle. So my recommendation is that you try to write this thing using either pi or odd values of pi or even values. So like 2 pi or pi. I suppose you could do pi over 2 if you had like 100 degrees. You could do like 90 plus 10, something like that. The reason being is what? All of those values on the x and y axis have values of 0, 1, or -1. So when we're plugging those into the formula, it's nice when I have zeros and ones because either things cancel out or I just don't really have to worry about it. So for this one, I'm going to start by saying, okay, this is the same as cosine of 180 plus 15. So by my sum and difference formula, this is what? This is a cosine sum formula. So that means if I look at my formula, it's what? It's cosine minus sine sine. So it's cosine of 180, cosine of 15 minus sine of 180, sine of 15. Okay, well, let's break this down. And again, this is why I use values of either pi or 180, 360, etc. Because what is sine of 180? Well, sine of 180 is 0, meaning this entire term is 0. So I don't have to worry about it. And then cosine of 180 is what? Well, this is -1. So this whole problem really changes into negative cosine of 15 degrees. So again, this one, the whole thing cancels out because sine of 80 is 0. So this whole piece is 0. And then cosine of 180 is -1. So I just bring the negative in front and I have just cosine 15 left over. Now do it again. So do I have any unit circle measurements that if I add or subtract could get me to 15? Well, I have several, right? I could do 60 minus 45. I can do 45 minus 30. You have a bunch of options. So I'm just going to do, but don't forget about this negative. This is like negative cosine of 45 minus 30. So this is equal to negative. And now cosine subtraction, which means what? Cosine, cosine plus sine, sine. So cosine of 45, cosine of 30 plus sine 45 sine 30. So negative cosine of 45 is root 2 over 2. Again, you should be using your unit circle. This is where we're using it. Don't get your kid. You're not even going to see me like say, okay, let's go to the calculator and see what this equals. We're not. We're not going to use the calculator at any point during these problems. So cosine of 45, root 2 over 2. Cosine of 30, root 3 over 2. Cosine of 45, root 2 over 2. Sine of 30, 1/2. So negative root 2 times root 3 is root 6 over 4. Plus root 2 times 1 is root 2 over 4. And you'll notice these both have the same denominator. That is what should happen with these problems, because you'll see as you do more of these that you are going to, because of how these formulas work out, you're going to end up with the same denominators regardless of the kind of problems you're doing here. So if all of a sudden I had like a denominator of 4 here and 2 here, I'd probably goof something up because that's not going to happen that way. So now since they have the same denominator, just combine them. So we have negative, we have 4 in our denominator, and then just root 6 plus root 2. And that is the exact value. That's not a value rounded to 2 decimal places or however many you think it should be rounded to. It's the exact value. All right, second one. Let's do tangent of negative 5 pi over 12. All right, so we have a bunch of different ways we could go about this. I'm going to show you what I recommend doing. You certainly don't have to do it because, again, you could add and subtract different values that are going to get you to negative 5 pi over 12. But the first thing I'm going to do is get rid of this negative inside using my even and odd functions. Well, is tangent an even or an odd function? Tangent's odd. So what happens in an odd function? The minus sign moves in front. So tangent of negative 5 pi over 12 is the same as negative tangent of positive 5 pi over 12. It's like, okay, well, that's great, but I don't know anything over 12. I'm looking at my unit circle, and George, you said I have to use the unit circle, and I don't see any pi over 12. No, you don't see that, but we can convert it, right? Because our big three are what? Pi over 3, pi over 4, pi over 6. So if I convert these all to have a denominator of 12, this is what? This is 4 pi over 12. And this one is what? This is 3 pi over 12. And this one is what? 2 pi over 12. So now can I add or subtract any of these that will get me 5 pi? Well, of course, it's these two, right? 3 pi over 12 plus 2 pi over 12 is 5 pi over 12. So I can rewrite this problem as negative tangent of these two guys, which is pi over 4 plus pi over 6. Now, what some students will do is they'll convert this to degrees using your 180 over pi. And then once you get that, then sometimes it's easier like, oh, it's 75 degrees. I know that's 30, which this one is. If you convert it, you're going to get 75 degrees. And 75 degrees is what? 30 plus 45. And so you can do it that way as well if you don't like this conversion to the 12ths. But otherwise, then we get what? We get negative, and my tangent addition formula is what? Tangent of pi over 4 plus tangent of pi over 6, all divided by 1 minus tangent of pi over 4 times tangent of pi over 6. So it's a negative. Tangent of pi over 4 is what? It's just 1. Tangent of pi over 6, root 3 over 3. And then 1 minus tangent of pi over 4 is 1 times tangent of pi over 6, root 3 over 3. If you want it, that probably is okay. I'm assuming WebAssign will take that. But if you want to simplify this and make it look nice, you could do what? You could multiply everything by 3 by the lowest common denominator. And so we get what? 3 plus root 3 divided by 3 minus root 3. And that's good enough. Like, I wouldn't worry about rationalizing it or do anything like that. Like, honestly, on a test, I would probably accept this answer as well. I'm assuming WebAssign will take this answer. I would take that as well on a test. Unless it does say, like, simplify your answer, no compound fractions or something. All right, so that's how we use addition and subtraction formula to find these exact values. We also have problems like this, so use addition subtraction formulas to simplify and then find the exact value. Oops, sorry, let me move that up. So use addition subtraction formulas to simplify and then find the exact values. So the first one, if I have sine of 20 times cosine of 10 plus sine of 10 degrees times cosine of 20. Well, if I look, remember, I told you guys it was like two-way implications. You could go left to right, right to left. What I want to know now is which of my sum and difference formulas have, never mind the angles, don't worry about that. Which formula has the form sine cosine plus sine cosine? Well, this is sine of s plus t, right? If I look at the formula for sine of s plus t, it's sine of s cosine t plus sine of t cosine s. So I can really write this thing, if this is my s and this is my t, as sine of 20 plus 10, which is what? Sine of 30 degrees. So this whole thing simplifies into sine of 30. If I look at my unit circle, what is sine of 30 degrees? It's 1/2. So you would have two answers for this one. Simplifies into sine of 30 degrees. Exact value is 1/2. What if I have tangent of 185 degrees minus tangent of 50 degrees, all divided by 1 plus tangent of 185 degrees times tangent of 50 degrees? Well, let's look at our formulas. Which one has the form tangent minus tangent over 1 plus tangent times tangent? That's, of course, our tangent of s minus t, because this minus in top tells me what is in the formula. So if this is my s and this is my t, this is the same thing as asking me what is tangent of 185 minus 50 or tangent of 135. So this big mess here is really just saying what's tangent of 135. And if I go to my unit circle and look at it, the answer is what? -1. All right, the last kind of problem that I want to work here. So I didn't put any of these on the mastery set because they are a little bit lengthy, and I didn't want you like messing up a sign or something and then uh you know doing a lot of work and not getting any points for it. But there is one of these on the in-class assignment. You will probably have one of these on the exam, either the midterm and or the final. So I do want you to know how to do these. Technically, you already know how to do these. So I have the following: write the expression, write, let me flip the page and start over. Write as an algebraic expression So I'm going to stop right there for a second. Write as an algebraic expression. That means this is what kind of problem? I'm going to pause here as you think about it. Let the wheels turn, let the smoke come out of the ears. These are what kind of problem? Always, 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 when you see write as an algebraic expression, this is a build a triangle problem. How this one differs from what we did before is we're going to have to build two triangles, but the method to what we're doing is the exact same. So write as an algebraic expression, and because I'm having two triangles in X and Y, and I have sine of cosine inverse of X plus tangent inverse of Y. So this means what? This means I want a final answer that only has X's and Y's and numbers. That's it. No trig functions, no inverses, nothing. Just X's and Y's and numbers. So what was our build the triangle methodology? We set the inverse part only equal to theta. We took the trig function of both sides to get rid of the inverse. We built a triangle using SOHCAHTOA, built a right triangle using SOHCAHTOA. We found the missing side. We rewrote the original without the inverse function, and then we solved what was being asked. So I'm going to do the same steps. First of all, I'm going to set this guy equal to theta. So I have theta is equal to cosine inverse of X. Take cosine of both sides, just like we did before. So I have cosine of theta is, these cancel out, X or X over 1. And so I build a right triangle with my theta. And cosine is what? It's adjacent over hypotenuse. And so I'm not going to waste your time on the video here, but if you need to calculate it, fine. When I do Pythagorean theorem, this missing side is going to be square root of 1 minus x squared. Again, just do Pythagorean theorem. You should get that if you need practice. That's one, but I have this guy too. Now, I am not going to call him theta, because otherwise later on in the problem, I don't know, do I mean this theta or do I mean that theta? So I'm going to call it phi, a different variable. You can call these alpha beta, you can call it whatever, delta and epsilon, whatever you feel like calling it. I just wouldn't call it X and I wouldn't call it Y, and definitely don't call it theta and theta because that'll confuse you. So we get what? Phi is equal to tangent inverse of Y. So tangent of phi is Y over 1. Build our triangle. So this is my phi triangle now. Tangent is opposite over adjacent. And so the hypotenuse by Pythagorean theorem is going to be 1 plus square root of 1 plus y squared. All right, so I built my triangles. I've completed them using Pythagorean theorem. Now what do we do? And like I said, this is the step everybody always forgets, and especially on a problem like this is ultra critical as to what we do next. And we do what? We rewrite the original without all the inverse pieces. So I'm going to rewrite this as sine of theta plus phi. And now be careful here because what some of you guys like to do is you totally forget that we have addition and subtraction formulas. And you're like, oh, this just means sine of theta plus sine of phi. No, it does not. Where's my big red pen? This is not equal to that. We don't, sine is a function. It's like if I have a square root function, I don't just start distributing the square root to everything. You can't do that. Same thing here. This is not sine of theta plus sine of phi. I'm going to distribute sine. No, you can't distribute functions. This is my sum and difference formula, which means what? Sine of theta cosine phi plus sine of phi cosine theta. And now you see why we need different variables. Because if I called everything theta, I'd have sine of theta, cosine theta, sine of theta, cosine theta. And I don't know which is this talking about, the first theta or the second? I'm not sure. So that's why you have to rename them different variables. Now go to your triangles to figure these pieces out. Sine of theta, so use the theta triangle, opposite over hypotenuse. So square root of 1 minus x squared over 1. Cosine of phi, 1 over square root 1 plus y squared plus sine of phi, y over square root of 1 plus y squared times cosine of theta, x over 1. And now, like magic, like I told you before, they have the same denominator, right? So this piece here is square root of 1 minus x squared over square root of 1 plus y squared plus x times y over square root of 1 plus y squared. If these have different denominators, you've not done the problem correctly. But because they have the same denominators, that's what's going to be in my final answer. And now I just add the numerators. So square root of 1 minus x squared plus x times y. And that is it. Do not try to rationalize. Do not try to simplify. It's not going to happen. You're not going to make this thing look any nicer. Any algebra you do is probably only going to make it look even worse. So that's it. Those are all the examples for sum and difference formulas. Come on back and we will see you for lesson number 11.